What's up, everyone? Welcome to Simulation. We have an awesome episode coming at you. We're going to be talking about data visualization. We're going to be talking about complex systems and simplifying them. And we have a very special guest. We have Matthew Rastovac. Hello.
Nice to have me.
Thank you for coming on to our show. Really appreciate it. Matt has a great background. Matt's background is as a software engineer. He's in his last year. He's going into his last year right now at the University of Illinois at Champaign-Urbana, or at Urbana-Champaign.
Got it.
UIUC. He is also a co-president at Founders, which is an entrepreneurship club in Illinois, the entrepreneurship club in Illinois. And then he also interned at NASA and interned at Facebook. NASA last year, Facebook this year, over the summer.
Yep.
And he's been working on visualizing complex systems. And we got some really cool visuals to show you and to talk through today. And let's go ahead and jump in, because I love young people and I love it when we get to talk to young, smart people. So
careful where you say that.
Yeah. Well, hopefully we can get past that taboo. Yeah, exactly. Okay, so let's talk about this, because I think data science and data visualization is only getting more and more important, because we've talked about this on the show so much, but the second greatest invention of mankind is all the data we leave behind, but the first greatest invention is how do we analyze it and make it applicable to our lives, and we have no idea how to do that. And so you're starting to figure out how to do that.
Exactly. Yeah, so as we've been getting so much more data in various different formats and various different ways, it's been getting more complex. The world has become much more complex and just full of this data, and we don't know how to analyze it. And so we've had different approaches. Machine learning has done a great job of sifting through giant data warehouses for various companies, for good social uses, for commercial purposes, but we still don't understand a lot of it, particularly in the social realm. I mean, Facebook exists, and I spent the whole summer there, and the more I spent time there, I realized we just don't have the tools ready for doing meaningful analysis on social networks. I mean, we still struggle with the question of how do we make people happy? How do we get more people to connect with each other, find more friends for them? How do we manage their relationships, keep them in contact with each other? And so I think that there's a very large skills gap in terms of the people who can do this stuff and the people who are doing this stuff and building the applications. Complex systems has been traditionally a very theoretical field where researchers look at small scale analyses of the economy, of social networks, of just various different social institution analyses, and they make conclusions that eventually, if you dig down deep into it, it goes, I don't know. There's lots of assumptions thrown around, and I feel like there's definitely a space for making real applications that can affect millions of lives and make people overall more happy by connecting together.
And this is a little cybernetics-y, right?
Well, I guess it depends on the specific definition of cybernetics.
How systems function and work.
Yeah, I mean, it's exactly. So when you're analyzing the way that a social network works, I think a lot of people have misconceptions about what does the world look like from a top level of who has the money, who has the resources, down to the average citizen. And these misconceptions get in the way of proper analysis.
Yeah.
If you assume that everyone has a network at least similar to yours, I think that you're going to be a little disillusioned with the way that society actually works.
Yes, you're giving us these really good examples, kind of on these different scales. You have like, okay, here's who Matt is, and here's Matt's like family and friends and his coworkers, and here's his like Dunbar number of 150 people that he can closely make connections to and know off the top of his head, etc. And then there's this crazy other side of this continuum of thought, which is the economy. How does an economy work? How does money actually move through the economy, through these trusted relationships, through earning money, spending money, all this crazy stuff? So then there's this massive scale, this small scale, everything in between. And I think we should talk a little bit about like the philosophy around it, because I think a lot of the political polarization is driving us towards this sort of binary thinking, like the economy is either yes or no, it's either black or white, your network's either black or white, but it's so nuanced, there's so much gray area, there's so much to actually unpack there. And it starts with oneself just being able to say things like, I don't know. It starts with I don't know. It starts with admitting that if I have a thought, like for example on, let's say, an issue like immigration, I should know everything that's all the way pro-immigration, all the arguments that are all the way against immigration, all of the arguments in between for all of the different variables, and that shows you how that shows you how educated you are on that topic if you know all of those different arguments. Now, the same can be said about economy or about people networks. So talk to us about your philosophy about complex systems and the nuance, the gray area.
Sure. So to me, I think that there's very few, if any, things in life that are black or white. Everything to me seems to be very gray, and hence why I wear almost all gray almost every day.
And I'm just wearing a Europa shirt.
Yeah. I don't know what that means, but
it's a moon of Jupiter.
Ooh. Okay. Yeah. Well, I know Europa.
Yeah.
I don't know like what that indicates about you.
Yeah. Oh, yeah. So, that indicates about me. Maybe that means that I'm a little bit more eccentric, like unusual.
I think that makes sense.
Yeah.
So, everything is a spectrum, and one of the things that plagues public policy particularly, is when they try to kind of pigeonhole all these very complex issues into, let's make a law that does this. And that's why immigration, abortion, gun rights, all these very hard questions are so difficult to solve, because people want it one way or the other. And that polarization is partially in fact to that, or partially due to the fact that there's so many different possibilities that could work under different circumstances. And that's kind of the point of complex systems. If you have some kind of effect, so the number of mass shootings is an effect of the system, then there could be multiple causes, and if you change the structure of the system, then that could potentially change the different causes and how they operate. So for example, if you take the gun rights policy issue into the Netherlands, then it becomes a much different problem, because there's a completely different culture there.
Yes.
There's different laws in place already there. People have different ideas and philosophies. And so our arguments completely don't translate. And so that's kind of the point of complex systems and why I'm so interested in them. It's mostly out of frustration about how the world tends to be simplified down by our feeble brains into these yes or no or A, B, C, D, E solutions. And I think that's not the way it should be. But unfortunately, I think that anything beyond those types of solutions are beyond the ability of most people to fully grasp and comprehend, and we don't have all the mental energy in the world, so it makes sense that over time, evolution has told us if you can make a split-second decision for yes or no, hey, I mean, that probably works in your favor.
Cognition saves you mental
Saves you energy.
Yeah.
You can get the food,
get the food.
That's really what it comes down to.
So you mentioned something that I think was so crucial, which is an effect and causes on that effect. Mm-hmm. And I think that if we start looking at the world in that way, I think it'll really make us much more aware beings. So for example, you took the amount of people that died due to mass shootings, and that you took that's an effect. So whatever that number is in the last year is an effect. Now, to say that it's caused by one variable is ridiculous.
Yeah.
And it's even ridiculous to say it's caused by a dozen variables. So now you're basically trying to look at a piece of data, which is this effect, and then you're looking at these causes and the weight of that cause on the variable, which is the effect. So all of these are different variables with different weights that are impacting this. And then if you take it from the US and you move it to China or the Netherlands, it's completely different.
Yeah.
So these systems are, and this is one issue. This is the amount of mass shootings per year, right? So that's different than the amount of guns that are sold, which is a different variable itself. This is different than the amount of people that are in mental institutions. That's a different one as well. And then that's different than all the other complex issues like immigration and like you were describing all the other ones. So this is why it's so fascinating to me as well, is your frustration with the polarization, with the binary thinking, with the A, B, C, D, that's it, these four choices, that's it, that I have that same frustration, and I'm trying to push people to have more nuanced conversations, more thought-provoking conversations, and I think that's one of the reasons why you and I definitely resonate
and I
so
think
much.
that it's tricky because there's no solid solutions you can gain by this perspective shift. Really, I can't tell you how to solve the mass shootings issue or how to solve abortion rights in an equitable way. All I can say is it's really complex, right? And I think that that's valuable in its own way. It allows you to have a different lens on the world, but at the same time, it's frustrating in a different way of I understand now that you can't just bucket this issue into two different ways of solving it and just pick one, call it a day. But I also can't solve it by knowing that it's too complex to solve in those ways. So that's another issue I think that still plagues me today.
And let's go through some of the visualizations that that you've made. I think these are really solid, and these are good different examples. They range across a variety of issues that you've built. Your website is pretty simple. It's mattrasto.me, and we have that link in the bio, mattrasto.me, and you can go and check it out. Check out his projects, workshops, blog. So as we go to projects, we see that you have your project toolbox and it's sorted by different projects that you've worked on, and we're going to pull up a couple of them and show them to you individually here. So let's pull up Exchange first. So
I guess I can go into it. So I guess Exchange was my first intro to programming, and you can probably tell that by the wonderful look of my Bitcoin exchange. And that's how I got into programming in the first place back in, it had to have been 2011 or so, back before I used GitHub. And so I built a Bitcoin exchange because I liked the idea of, look at this new way of sending money. And it was really the first challenge to my traditional views of the finance system is how it is, and it's not going to change. And then Bitcoin came along, and all of a sudden I could think about, wow, you can program people's behaviors, and not in so much of a dangerous sense, but you can align incentives so that people will naturally want to spend more Bitcoin, or they'll want to mine instead, save up in different ways. And I think that that was really my first foray into complex systems in a way. And nowadays there's somewhat established field, mechanism design and token economies, and those are evolving pretty rapidly.
How are you tweaking the variables? Because here, if we zoom in, how are you tweaking them to get people to potentially mine more or spend more at a given time, etc.? So
that wouldn't be on the exchange. The exchange was just something that I could do to learn more about the space. But in general, for token economies, let's say you make it so that, let's compare Bitcoin versus Litecoin. You have much smaller block size, on Litecoin that allows you to do transactions faster. The fees are typically lower, but that means it's not well suited for putting a lot of data in those blocks. And so you get the trade-offs. And incentive mechanism design is all about the trade-offs. What is best for our target audience, and how do we program in the right incentives so that they're happy? And that's why we have so many different token economies now. We have Bitcoin, Litecoin, Ethereum, Dogecoin was big for a while, probably still is.
We have so much stuff to cover, especially what your most recent AI concept map that we want to show.
True.
So maybe let's speed round through these.
Go for it.
Should we keep going then? Keep showing.
No, I think that
show the next one.
Yeah, it was a challenge to my philosophy, and that's about all there was.
Good. A simple HTML parser for biochemical research results to aid genomics researchers, geodata.
Yeah, so that was my first internship at a pharmaceutical company, and this really spoke to me. It was my first real programming job, and they asked me to sit in a cubicle and look at a website and copy and paste data into Excel all day, and I was like, no. Mm-hmm. So I wrote a program to do that, and that was just something that it went from like 60 minutes to 30 seconds you could do it in. And
from 60 minutes to 30 seconds, that's fantastic. Way to save time.
Yeah.
Damn.
I think that's important for any
so
hustler or
important.
hacker. Just learn how to automate and have an obsession too.
Yeah, have an obsession with saving time with automation with code all day.
Yeah.
Good shit. Good work. Hell yeah. Okay, so then let's go to Ab Changer. So
I think it was Ab Cruncher.
Sorry, Ab Cruncher. My bad. Ab Cruncher, a visualization platform for analyzing interest relations between drug researchers.
Right, and so this was my first formal intro to data visualization and complex systems, and it was in the social space. So at AbbVie, that's where the name came from. It was a data cruncher for AbbVie, so it was named Ab Cruncher.
Yes.
Which is interesting choice. I don't know if that was intentional. So it's a very large company. Lots of PhD, bio and chem people working on experiments, and sometimes they would work on the same experiment in different buildings, facilities, and they wouldn't even know about it, so that would waste 6 months, and PhDs are expensive. So they wanted to stop that. So we wanted to just create an interest graph of all the researchers at the company based on the data they put in their internal profile, what their focus was in, whatever. And that way we could take a look at an interface like this to see what is who would you possibly be connected with, and maybe that would inspire collaboration. And hopefully it did. I think there were a few cases of researchers who said, oh, hey, I should probably talk to this person.
And so they could maybe optimize each other's processes by engaging with one another.
Exactly. Just connecting people in a meaningful way. I think in a work context, great.
Huge. Yeah, it's huge too. Okay, cool. And then here's another good example, and you got a little.
Yeah, and you can watch the video on my website. I think I was sick while recording it.
And this is good. Like, you have examples here of very connected, more connected, less connected, barely connected. And that's a good way to get people to be like, oh wow, there's possibly a really good collaboration potential here. So,
right, and there's different ways to do the layout, whether you want to see the people connected to you or see a specific interest in everyone who's connected. And I think that was a really valuable experience.
And then let's go to Verano.
Yeah.
A web application for financial data analysis.
So I kind of went into complex systems, and then I realized that there's a lot of research to do. So I kind of got intimidated, and I moved into data science / machine learning. And so very specifically, I was doing time series forecasting, which is predicting ahead of time on a time series, like a stock chart, data over time. And so Project Verano was a project I did with a friend from high school in over 3 summers ago. And all it was you look at the S&P 500 and you plot it over time. And you could detect volatility in it, and you could detect, I think, rises and runs. So very basic, but I wanted to get more experience with D3, the main visualization library I use.
And tell us a little bit about that visualization library, D3.
Sure. So if you want to do visualization on the web with any kind of data, a great starting point is D3. It's a way to add nice, pretty graphs to your website with fairly little code, depending on how complex you want to make it. And it's almost a de facto framework for anyone to use in visualization. And so it's very popular in that field, and it works very well because it's on the web. And that means that everyone with a browser can use it, see it, and interact with it. And that's one of its core things, that's interactive. So we'll see that in the concept map.
Yeah, exactly. So I'm really excited about also introducing more people to D3, because I think it'd be really good to have more people be aware of data visualization tools and integrating that into their flows. Cool. So then you were able to learn about the volatility here of the S&P, as well as the bulls and bears markets.
Right.
That's good. So there's tons of different things that you learned here. You know, you were learning about how to best connect people. So much other work, which it's great to get you kind of flowing with these projects.
Right.
I keep telling people that it's crucial to get them a portfolio. Right, that this general
portfolio
idea.
is the number one thing I recommend to any programmer. They always focus on, like, should I do research? Should I try to do a summer job more aligned with my area? And it's kind of a chicken and egg problem. You can't get a job without experience and experience without a job. But a portfolio is a way to just throw a wrench in that whole problem, that whole system. Just say, I've done side projects like this. And I know how to program in these languages, and you can see it on my GitHub or on my website.
Yep.
And that's a great way to signal to employers that you're actually worth the risk of onboarding. And that's their number one concern. Like, are they going to be a productive employee? And if you can show them I'm productive.
Yep. And the general idea of having a place where you can showcase what you've built.
Exactly.
Yeah.
And that's my favorite thing to recommend specifically is you make one personal project and then you make a website so you can display that personal project on your website.
That's perfect flow. Make
You've
a
already
personal
got two
project
things.
or two, and then make a website, and then host those two on that personal website,
Exactly.
and you're good to go. And then just keep adding what you make to your website, so that way you have a log of who you are, what you've made, etc., and being able to showcase that to people.
Yeah.
All right. So let's go ahead and start talking about the AI concept map. So. So maybe we should start, maybe even before we get to this dynamic one, let's show the static one.
Sure.
Sure. All right, let's show the static image that we have, Ron.
So I think it would be the other one then.
Well, this one's the static one, but what is this one then?
So this is with phase.
This is the GIF. Yeah. Okay. Can we show the static image as well? There's a static one too, right?
It's right below it, I think.
It's right below. Is it right? It's okay.
There's two images I have here.
Yeah.
This one and
Yeah, there it is. Yeah, the static one.
Yep.
Yeah, go. Yeah. Okay, so now, what's going on here?
Okay, so this one. So this one is with.
This is related to this, right?
It's not.
Oh, it's not.
We could also just go off of it.
Okay.
the
Well,
dynamic
what's
one.
this one then?
This one's with phase.
So this one's. Oh, that's next.
Yes.
Oh, okay. This is next. Okay, sorry. So then you were right. Put up the GIF again. Yes, because this is This is where we'll go next.
Yeah.
And this relates to the AI concept map that we have pulled up right now. So we're about to play that GIF. All right, so here it goes.
Well, this GIF is also with phase.
It is also with phase?
Yeah.
Okay. So then we'll come to this after we go to AI concept map. Okay. Okay, cool. So then, all right. So Ron, we're going back to the NDI connection for now, and then we'll go to this. So we have your AI concept map. So tell us a little bit about this, because you were teaching me about the, these are relationships between machine learning concepts.
Yes.
So it's this idea that if you come in and you zoom in, you can see, oh, there's unsupervised learning, reinforcement learning, all these different sorts of machine learning and how they're related.
Mm-hmm. Yeah, so one of my problems when I was starting to really dig into the machine learning space was what is an RNN versus a CNN versus just a normal NN?
And an RNN, CNN, explain what those are.
So RNN, recurrent neural network, CNN, convolutional neural network. I was like, are those different than a normal neural network?
Mm-hmm.
Or are they subclasses of it?
And are they different?
So RNN and CNNs are both subcategories of neural networks, and they do different things.
Yeah.
And they have different uses. And so if we were to look for that, we go into the neural network section. So we see there's general neural networks. And then we see RNNs.
And neural networks are part of supervised and unsupervised learning.
Right, exactly.
And so you see how you programmed it so that when you put your cursor over it, it would highlight where it connects to what nodes.
Yeah.
And then you zoom in here like you were doing, and you see which.
Right.
Yeah.
Oh, it looks like I found an error. But so
where? Yeah.
An LSTM is actually a type of RNN. And so there's CNN and there's RNN, and those do different things, but they're both subclasses of neural networks. Mm-hmm. And so I wanted a way to visualize the whole space in a simple way.
Yeah.
And I thought, it's a graph. So let's make a network visualization. And that's exactly what I did. And so if you want, let's say you come in and you're very confused about the machine learning space. You've heard all these different concepts during maybe Andrew Ng's Coursera course. Yeah. And you're like, okay, how does this all fit together? Yeah. So you just start at machine learning, the center. You can learn about what it is, when to use it, how to use it, the different tools, libraries that are available for it, maybe the top ones, and then some extra links. I even linked to Andrew Ng's course here. Mm-hmm. And then you say, okay, well, I want to specifically go into, let's say, supervised learning. So you click here, and then you can learn about that, what it is, and then see that, from supervised learning, we see that there's neural networks. You can do naive Bayes or different types of regressions, SVM, support vector machines, all these things. And it gives you just a more holistic view of the space and kind of demystifies it, which is a common theme now.
Which is what we care a lot about, is demystifying complex things to more simplified ways of understanding it, but also with still caring about all of the different variables that go into it. This is really great. This AI concept map is just it's fantastic. You go to clustering, it's it's part of dimensionality reduction. Yeah. and there's all these different types of clustering that happen. Semi-supervised learning. This is great, and you can you click and drag. It's dynamic in the sense.
Fun to play with.
Fun to play with. When I click semi-supervised learning, you have, not for now, but soon. Yeah, soon there will be. Eventually you'll have these written up, and it looks like this functions so interestingly well in a three-dimensional. Right. It looks like it's.
And this was fairly simple to build with D3 too.
This is fairly simple to build.
There's a lot of boilerplate stuff that you need to add in, and that's one of the reasons why I made phase.
Sweet. So then let's go to phase. Is there some more that we should show here?
No, I think that.
Let's do it.
That's about it.
Okay, let's pull up the GIF now, Ronnie, or the static image, or GIF.
The GIF would be good.
Let's do the GIF. And the GIF is relating to the AI concept map, or
so this was it's relating to the framework, but the framework was inspired by problems that I ran into when developing the AI concept map. Yeah. So this is kind of a bunch together. There's a lot of text and lines, but This is a network visualizing the actors in the Les Miserables.
In the what?
Les Miserables.
Oh,
play.
Les Miserables play. Oh, this is the actor?
That's crazy
Yeah.
that you just said that, because I just emailed my GFE and see if she wanted to go to Phantom or Les
Oh,
Miserables.
interesting. Yeah.
Isn't that crazy?
That is interesting. Just a little bit ago.
Wow.
Yeah.
And so,
Sorry.
And how they're and now you're showing how they're related.
right, so this is a very famous data set, and so I use it for a
Okay.
lot of my demos. I'm not really sure what the links represent. I think it's just like which scenes they are in together.
Okay.
But it's great for if you want to do any kind of network analysis. So in this case, what we see here is we're doing a breadth first search. So we're searching through the graph, starting from count. It'll turn purple first,
Yep.
right there. And also Boulatruelle.
Yeah.
And from there, it colors them at different levels. And it, okay. So it expands until it hits the whole graph. You can see which characters are furthest away. So the ones that eventually highlight orange are the ones that are furthest away from Boulatruelle and Count.
Yeah.
So this was very easy to build. I think the demo ends up being only a few lines. And to me, that's the goal. That's making it easy to do something like this. And building on top of that, you can take any kind of network with any kind of structure, with any kind of simulation or visualization that you want to do, and do that simply. So building the infrastructure for complex systems researchers to effectively do their analyses.
Yep. Yep. And look at this. This is an analysis on actors, actresses in Les Miserables versus the economy. It's a whole different scale, different variables. It's so interesting how these things differ. And let's go ahead and talk about some of the other like bigger picture stuff as well, because I think that's so fascinating and important to talk about. Okay, so we've been talking about complex systems, how to visualize them. This is important. I don't think we've talked too much about simulations. So when you take a complex system like these cause and effect structures within a topic, a hot button topic, let's say like abortion or whatever, and then you are then trying to figure out, maybe run a simulation. Now, how would you go about doing that?
Ooh. So trying to visualize what about abortion? Because there's a lot of different ways you could go about it. Let's say you want to visualize all the main, like let's say the politics of abortion, like who are the people in Congress, in local governments, etc., who are involved, and what are their leanings, and then like how do you take advantage of that to run a simulation and say like if you started a movement in Anchorage, Alaska, right? Would you be able to affect the national view, majority view towards the abortion issue? And so that's one thing you could do. Just make a network, model all the politicians, their circles.
Yep.
Or you could model the population itself.
This sounds so difficult to do.
It's extremely
to model
difficult.
their
You gave me a very
positions.
difficult problem to model.
Yeah.
But I mean, those are the ones that I think are important to tackle as well.
Yeah, yeah. And then you can open source that data set of terms of how the politicians stand on this issue
Exactly.
of abortion, and then other people can come in and run other simulations on, what happens if a different movement starts in Birmingham or in Detroit, et cetera.
Exactly.
Yeah.
And there are some data sets that exist. I mean, there are websites that keep track of every politician's past vote, or like what are their political leanings and who do they associate with, what committees are they on, and so that data might be available. It might be in the wrong format, or you just don't know how to find it or scrape it. Maybe they have a really bad API to get the data from, and so I want those to be the main problems that people are solving. Hopefully those will get solved by other frameworks made by people with better expertise in those areas than I. But I want the visualization part of it. Once you have that data set, like what do you do with it? I want the barriers in the way of making those kinds of simulations, gone. And that should enable the average programmer who doesn't have expertise in D3 or whatever library they choose to work with to just do their meaningful analyses with the data that they find elsewhere and use that to inform people, to enact change themselves, to build applications on top of that. So maybe for the economy, they do an analysis and they realize, wow, this is a very underserved sector because there doesn't exist a company that does X. Like autonomous vehicles need, autonomous headlights. I don't even know what that means, but
Maybe
if you solve that problem.
Yes, that was good. Thank you. We'll start our timer. 15 minutes. Just
Okay.
a couple thoughts there. First thought is that it's interesting to take something else, maybe like how a commodity moves in the economy.
Yeah.
Something like toothpaste.
Yeah.
How does toothpaste move in the economy? And what areas buy the most toothpaste? Why do they buy the most toothpaste? How soon will Africa want Amazon to start be shipping toothpaste to Africa?
Exactly.
Will Alibaba come in and ship more toothpaste to Africa? Who knows? And so how to model these things out? Well, does Crest have the market share? Does Colgate have the market share? Are those both Procter & Gamble companies? I don't even know.
No idea.
I don't even know, but P&G's fucking
Wouldn't be
everywhere.
surprised.
Yeah, I know, with just two different brands. And then so maybe another idea is to just as you market out the way that underwear is shipped and moved across the planet, or even something like iPhones and cell phones. So all these different sort of commodities can also be simulated in different ways. It would be like if you basically took that bubble on the AI network that you made there, the concept network, and you clicked and dragged it over to maybe a different area, and you said that, let's say that the manufacturing facility moves to a cheaper labor area. Now, how much, this would be a simulation for maybe Procter & Gamble, is how much more money would you make for the shareholders? How much faster would you produce the toothpaste? Exactly, all these different variables that can be analyzed.
And economies are, I wouldn't say they're easy to simulate, but they're easier to simulate than people. So like doing idea.
Psychometrics are hard, but companies
They're hard and subjective, and
Yeah.
all the data is very skewed and stuff like that. And so with the economy, you have dollars. You have a very defined metric that you can use. Say like, okay, if we move our factory over to, where was it? Somewhere
Let's
in
say move it to Central California. And
Central California.
Yeah.
Then, will your customers, or will your logistics companies be able to get out there with their shipping supplies and ship
Yes.
it all over? Do you have the right infrastructure in place? Do you have to buy a warehouse? Whatever, all these decisions, you have a dollar value attached to it. And so you could run a simulation on how many people do you think would buy it? If that doesn't change customer behavior, then all you have to do is simulate the worst case and the best case, take the average, and try to see what is the actual value of that action.
Yeah, and to be able to map out the value of different simulations is a fascinating ability. And I'm really happy that that you're studying data, you're studying visualization, you're studying simulations. Can you teach us about chaos theory quick? Chaos theory, is that like the butterfly effect?
Yes, so chaos theory kind of is the basis of the butterfly effect, and I'm no chaos theory expert, but essentially what the theoretics behind it is, chaos theory, you have some kind of system, and if you make a small change to that system in its early phases, so for example, if you have the US, you take out the president.
It's like the smile thing.
Right.
You're on the street, you smile, the next person will be like potentially smile, it could butterfly effect.
Right.
But yeah,
so changes in initial structure, initial changes in the structure of a system will have unpredictable / large consequences in the end state of the system. So if you take the social network of the US, take out the president, just one person, right? That won't affect it all that much. massively different.
Massively different, yeah.
That's
Yeah.
an example of the
But what
butterfly
if we
effect.
took you out of the system, or me?
Maybe,
Yeah.
right?
It would
Maybe I don't
it
have
would-
an effect.
Maybe it would have less of an effect. Yeah, yeah.
Yeah, and so
It still have an effect.
tweaking,
That's
you're
a lot
tweaking
of
some
no's.
initial condition.
You would have an emotional response from like your mom and your dad, your family, and then you'd have an emotional response from your friends. And that
Exactly.
would cause, exactly, different,
Yeah. And so maybe that slight emotional change in my friend could lead them on an entirely different life trajectory.
path. Yeah, exactly. Yeah,
Remember
exactly.
the emotional response you had at Toulon restaurant? Remember
Yeah,
that?
yeah, I remember that.
That was the most I've ever seen you
See?
get emotional. Yeah.
It's funny because it's gonna even get even less sort of aggressive and agitative as we go to my fourth meditation retreat. Ron goes to his first in the fall. We'll be going to that. It'll be a lot of fun. We've covered so much stuff. I think this is interesting. You were talking about this on the way out. We can talk about this. The way that a simulation can be used for psychometrics as well. There seem to be, the benefits are things like, oh, I have no friends in this area. I just moved here.
Mm-hmm.
And it's like, fuck yeah, we have tons of people that we can get you as
Exactly.
friends because, we know your interests, we know their interests, we know they're also looking for friends. Boom, there you go. Now you have tons of more friends. And so it's stuff like that that makes me feel very optimistic and happy. And then there's the, analyzing people's psychometric profiles and then feeding them hate ads, which I think is disgusting and I think really needs to just get completely extinguished. Thank you. There we go.
Get it out.
Extinguished
Little
from,
opposite
from
there.
society. Yeah, exactly. So there's that. We gave all these great examples about the economy. You actually were teaching me about how, and I thought this was really interesting because I have also been kind of talking about this, but not from this perspective that you taught me about it, which was that maybe the reason why the economy functions the way it does is because of the relationships that people have with each other. As in, you and I are starting to get closer. Now it's much more likely that you and I might go and spend money between each other, spend money with each other, that kind of a thing. And that's like when you have your mom or your dad are much more likely, from age 0 to 18, they basically pay for everything for you.
Yeah.
As someone that's being birthed into the world and growing into the world. So just this idea that, the parent is going to be responsible for paying for everything for you. But for example, someone on the street has no interest whatsoever in paying anything on your behalf in almost every single case.
Right.
So just this general idea of this nuclear family, and the way that the nuclear family functions in an economy, and the way that things like, that's kind of like more nationalistic in the sense, and then the globalistic sense, and if you were to maybe like get dosed up with LSD, or if you were to maybe go through tons of meditation practice and just eradicate your ego and understand the whole we are one mentality and stuff, that actually, and interestingly enough, was some experiments of the MK Ultra,
Exactly.
which is just crazy to think about this, but if you break the nuclear bonds of that structure, it changes the way that the people interact within the family and also from outside of the family in. It changes and maybe increases the idea of a family to the planet, and then that changes the way that economies, markets work, borders work, nationalism, globalism
Exactly.
works. Yeah, it's a difficult thing to explain.
Yeah, I mean, so a few thoughts on that then. Yes, the economy is an emergent property of some system, some social system. And so that means the economy of the US is vastly different from the economy of China.
Yeah.
And that's because we have large structural differences in those systems, the way people interact. China has a very strong family culture. In the US, that's sort of starting to disappear. And so governments, being organisms that want to survive, constantly competing against each other and internally to make sure everything's functioning properly. Backtracking a little bit, if you change the fundamental structure of the system too fast for that government to adapt, so let's say the family ties in the US just like completely disappear in 5 years, whether by some just like radical cultural shift or something else, then the economy would change, or the needs of the economy would change maybe too fast for the government to keep up, and the government would essentially not be able to function and adapt, and it would cause a lot of tension, possibly a collapse. And so governments are very aware of this, and so they like to keep things in an innovative stasis where there is progress being made, but at a pace that the government can keep up with. And that's why I have such a large hatred for bureaucracy.
Bureaucracy. I was going to say, this is something I acknowledged a long time ago. All bureaucracy does is just gives the chance for those that are in power to figure something out to really stay in control. Hey, while we're at it, I just wanted to shout out to Fernandez Ramirez, who's watching. He always watches and he comments. He thinks the graphics are cool. I just wanted to do that. Thanks for watching, Fernando.
Thank you so much for sharing and for watching. Thank you, Ron. Good shout out.
Yeah,
bureaucracy holds us back from innovation.
Dirty rat bastards.
But I think a lot of people get it wrong on why bureaucracy holds us back. And I think it's this.
It also keeps us safe in some ways.
Yes, in some ways, right? Adaptation, you can't have, like the cultures are very hard to change. And so if the cultures of a society change very quickly, you're going to have people left behind, and that causes polarization, tension between classes, stuff like that. And so, again, going back to this idea of being able to envision a system as complex and thinking about societies, about emergent properties of the world, like the economy or transportation, transportation lines, the way that industry works. Just think about all these things as a complex system, and taking lots of ideas from that field is, I think, extremely fundamentally valuable. In order to understand the world in its current state with policy, economics, how your social network works, stuff like that.
And you're right there in the nuance, in the gray area. You're right there making sure that people wanted to calculate all of the variables, understand that an effect doesn't have one cause, it has tons of different causes. So I'm really happy to call you my friend, and I'm very happy to be able to continue picking your brain over time and learning from you, amplifying it. We got a lot to mesh and a lot to work on together. I'm really excited for that. Let's ask you a couple questions on the way out. First question is, do you think we're alone in the cosmos?
No. I think that would be silly to say that we were. I mean, life evolves very quickly. I think I learned that from Jill, who we had a nice lunch with that last weekend. And the math would be statistically surprising, I think, if we were to end up alone. And I guess it depends on your definition of life. Intelligent life, or just like bacteria floating around. I think there's definitely bacteria floating around somewhere. Intelligent life, yes, but with stipulations. It's hard to tell.
And then, do you think that we're in a simulation?
I like to not think anything. I don't like yes or no answers.
We'll unpack the nuance of your answer.
Yeah, so I don't know. And is it relevant, really? I think that is the core issue of my problem with that question is, what does it change if we're in a simulation? Does it mean that we're deterministic? Would we be deterministic anyway if we were not? And to me, life seems inherently meaningless. So while I'm here, I'm going to do my best to make life as meaningful or as happy for as many people as possible. And I don't think that whether I'm in a simulation will affect that. I think that goal is kind of tangential to whether or not we are. From a thought standpoint, yeah, I think it's I think it's a real possibility. I think I'd lean more to yes. We have no way of knowing how long existence, even beyond our universe, has been going on. And I think that simulations, based on my work, are very useful. And so maybe there is some super intelligent race that's been simulating us. I don't know how I would feel about that. I probably haven't come to terms with that yet.
Fuck them. Hey, what's the most confusing thing about reality, being that you feel that life is meaningless? What's the most confusing thing about our collective reality? That,
humans.
Humans
are
a beautiful man.
Just so confusing and so complex, right? And I've said that word too many times, I think, in this hour, but humans are full of nuance, and I could spend my whole life studying them. Many people do, and I will never figure them out.
They're also full of shit.
You got it.
That's a new question that we've added to the show. What's the most confusing thing about reality? So that's a good answer. There's so much nuance to unpack.
You might get that answer a lot.
What?
You might get that answer a lot.
I will, yeah, exactly. Good. I hope we get that answer a lot. Okay, last question. What do you think is the most beautiful thing in the world?
Well, that's a hard one. That's a very hard one. I think I like sand a lot. Sand is neutral. It's just there. I think looking at a desert.
I wonder if I skewed his answer with my...
that's a good answer.
Oh,
I like
maybe
sand
it was
too.
primed.
I like
Yeah.
sand
Maybe it
on
was
my
primed,
feet.
yeah.
No, I've always liked deserts.
You do. You like deserts. Interesting.
Long
Yeah, I thought
desert
you were going to
views.
go to beach first. That's interesting. You went to desert. Yeah.
Oh,
I
there's sand on
find
the beach.
deserts fascinating as well. They're just huge.
open.
I mean,
Lots of
Sahara
conversations to
crazy,
have
Yeah.
about how living in a desert affects your frame of mind.
Ah, correct. Yeah, because that's like the meditation retreat that I was just talking about as well, is when you are away from social connections, when you're away from the internet, where you're away from all of the noise, what happens to your mind?
Yep.
Typically, we go and revisit memories. We find new ways of maybe finding water and food and ways to
Different
think
societies form in different environments.
societies form,
Jungle versus desert,
Yep.
very different.
Yep. Interesting. Can you just give me another 20 seconds on sand? Why sand is so interesting for you?
It's neutral. It's just there, kind of like us, right? There's so much sand, lots of humans. We are just like moving around in the wind. It doesn't really matter in the grand scheme of things where the sand ends up. It's still going to be on Earth, and although we may not be on Earth forever, we're still in the universe. We're still in some container, and largely we're part of nature, and that's really what it comes down to for me. We're just sand laying in the sun, soaking up heat, enjoying our time.
Yep, I love that. That's a very meditative sort of understanding of life and being happy. Okay, this has been fascinating, Matt. Thank you so much for coming on to our show.
Thank you for having me.
Yeah, I mean, there's so much to unpack, everyone. I really appreciate you guys tuning in. There's so much to still learn about data visualization, data science, making it as relatable as possible, learning cool things like D3 to be able to add this into our daily lives, understanding all the nuance and all of the multivariability of the way that things are affected by all these different causes, so that it's not just so binary or A, B, C, D. It's not just that easy. And let's get more people talking about this. Go and share this with more people. Comment below with your thoughts. Subscribe, join the family. Go and create with this content. Don't just consume it. Go make things. Go write a blog. Go make a program. Go and make a video about this as well. Join us on Patreon. Help support us. Help us scale this content. Impact more people. We'd greatly appreciate it. Thanks, Ron, our producer and director. Much love, everyone. Talk soon. Peace.